Okay, we'll start with Kubernetes, one more container orchestration software. So far, we discussed about what is containers, how to create a containers, how to create images, and we already discussed Docker Swarm container orchestration, using which how to manage our containers and how can we deploy the services in Docker Swarm. Kubernetes is another container orchestration software which is widely used compared to the Docker Swarm. Lot of people will use Kubernetes compared to the Docker Swarm. It's a popular container orchestration engine. We'll try to understand how to create a Kubernetes cluster and how to deploy the application in Kubernetes cluster. So this is the agenda for Kubernetes. First, we'll try to understand what is Kubernetes. Kubernetes is an orchestration engine and open source platform. It is open source platform for managing the containerized applications. The responsibilities of Kubernetes. What does Kubernetes does, right? So we can achieve container deployment, scaling and descaling of containers, and container load balancing. We can deploy the containers using Kubernetes. We can scale up and scale down the containers. And if we have a multiple containers, multiple replicas, right, it will load balance. Kubernetes services will load balance the request if you have a multiple containers for the application. So actually Kubernetes is not a replacement for Docker. Kubernetes will not replace Docker. Kubernetes can be considered as a replacement for a Docker Swarm. Still we use Docker. Kubernetes is a not replacement for Docker, but we can consider a replacement for a Docker Swarm. Docker Swarm is very simple to set up and to deploy the applications. But Kubernetes is significantly more complex than Docker Swarm. It requires a lot of work to set up a Kubernetes cluster and to deploy the applications compared to the Docker Swarm. But Kubernetes cluster is very strong, right? We will get a lot of features compared to the Docker Swarm. So who is, why Kubernetes is more popular and why a lot of people prefer Kubernetes over Docker Swarm or any other orchestration engine? First thing, it is an open source. And the second one is it is implemented by Google. The Kubernetes is a vendor. Initially, the Kubernetes vendor is Google. Google has implemented Kubernetes and later they donated to another company called CNCF. Cloud Native Computing Foundation. So initially Kubernetes is developed or implemented by Google. Later they donated to CNCF. Kubernetes was released to market in 2015, July 2015. Kubernetes initial release, the Kubernetes initial release, first release, released to market in July 2015. But now the latest version is not 14 version 1.14.0. Now actually it is 1.17. When I documented it was 14, but the current stable release is 1.17.0 as of today. So within 5 years, they also updated lot of things in the Kubernetes. So current stable release is version 1.17.0. So what are the features we will get in Kubernetes? Kubernetes has these features: automated scheduling. So Kubernetes has an advanced scheduler to launch containers. So there will be a scheduler which will schedule the containers on the worker machines. Kubernetes has an advanced scheduler to launch containers on the worker machines, our application containers on the worker machine. And self-healing capabilities. Kubernetes has a self-healing capabilities. The name itself is saying self-healing. What is self-healing? Self-healing or fault tolerance. So whenever containers are died, I mean to say whenever containers got crashed or deleted, and it will replace the containers. It will recreate the containers if the containers are down. If some of the worker machine itself is down, it will try to move the containers to the another machine. It will try to move the containers to the another machine. It will recover itself. The application containers will be recovered. Whenever one of your application container goes down, Kubernetes will replace the container. And also we can roll out and roll back the applications, deployments with very simple command, right? You can roll back to the previous state of your application, or you can deploy a latest images, roll out and roll back. And more importantly, Kubernetes support scaling, again dynamic scaling, manual scaling also, and also dynamic scaling. Kubernetes does horizontal scaling and load balancing. Kubernetes can scale up, scale down the application as per the requirements with a simple command, or automatically based on the load. You can manually scale, or you can dynamically scale the application containers. And the request will be load balanced between multiple containers. So we have a service discovery and load balancing. What is service discovery, right? We no need to worry about the IP address of your servers or your containers. So with Kubernetes, there is no need to worry about networking and communication. Kubernetes will automatically assign IP address to the containers, or it can set a DNS name for a set of containers. We have one concept called service in Kubernetes. We will discuss in detail. Your service name is nothing but a DNS name for the set of containers. So that can load balance the traffic inside the cluster. We will discuss what is a service, right? And how service will access, we can access the containers using service. So we can do the storage orchestration. With Kubernetes, we can mount Storage system of your choice. Again, values. Since we are dealing with containers, again we need to take values. We need to create a values and we need to use the values. Again, you can take a local value or network value. So first we'll try to understand Kubernetes architecture before we install Kubernetes, before we set up a Kubernetes cluster. We will try to understand Kubernetes architecture, very important concept in the interview perspective also, or in the understanding perspective also. In case of Docker, it was very simple. We have multiple machines. We have one Ubuntu server. On top of that, you just install Docker. In case of Docker Swap, right? We just have a Docker software. That's it. We have not installed any additional softwares. Here we executed Docker Swarm init. This guy become a manager. You executed the token here, Docker Swarm join command. So these guys joined as a workers. If you joined with worker token, we have not installed any additional software. Very simple. But whereas in Kubernetes, we need to understand the architecture. In master machine, what components will be there? In worker machine, what components will be there? So we have one server. Again, I am going with Ubuntu server. Here we should have a container runtime. Docker Swarm supports only Docker containers. Docker Swarm can orchestrate only Docker containers. But Kubernetes can orchestrate other types of containers also. We have containerization softwares like Docker, Rocket, RKT, like CoreOS. Container orchestration. We have Docker, Swarm, Kubernetes, or OpenShift. Right? Docker Swarm can orchestrate only Docker containers. I mean Docker containerization. Kubernetes can orchestrate Docker, Rocket, other like containerized softwares. But most of the people, 90 to 95% people are using Docker only. So by default, Kubernetes also manages Docker containers. So we need a container runtime here. Container runtime is nothing but Docker software. Docker or any other container software. In all the machines, you need this one. Then in master machine, you have few components. You need to install some Kubernetes related softwares. Then we need to create some Kubernetes components. In master, you have few components like this. We need to have these components: API server, scheduler, we should have control manager, then we should have etcd. These are the important master machine components. We have a few more, but these are the important components. In the worker machine, we should have kubelet, and we will have a kube proxy. We should have kubelet and kube proxy. On top of containerized runtime, you need to have all these components, then only it will work. The Kubernetes cluster will work as expected. So what is the role of API server in the master? What is the role of scheduler? What is the role of control manager? What is the role of etcd? What it will do in the master? And what is the role of kubelet and kube proxy in the worker machines? And how can we communicate with cluster? Right? We have one command line software called kubectl, or you can communicate using web application like UI also, GUI, graphical user interface. If I want to deploy something, some application in Kubernetes cluster, or if I want to delete some application, I want to scale up, scale down. So we can use kubectl, command line interface, CLI. Kubectl is a CLI for Kubernetes. So this is master. These are workers. We can communicate with the master machine to deploy the applications or to delete the applications, to create a volumes, whatever it is, we can do via CLI software called kubectl, or you can use UI, graphical user interface. So what is the role of master? In any cluster, what is the role of master? But in master machine, we have few more components we will discuss. What master machine does, basically it will manage the cluster. So the cluster is hosted by one node acting as a manager of the cluster, other nodes which do the actual containerization, right? So we have a UI, you have a CLI, kubectl, to interact with the master machine, to deploy the containers or to delete the containers. We have a command line interface which will talk to the master machine. Then we can manage the containers. So we have a Kubernetes dashboard or UI. Dashboard is a web-based Kubernetes interface. You can use dashboard also to deploy the applications in a Kubernetes cluster, or you can troubleshoot the applications from a dashboard. Whatever we can do from the comments, we can do from the dashboard also. And we have a one more thing, CLI. This one, kubectl. kubectl is a command line interface for a Kubernetes. We will use to interact with the master machine of a Kubernetes. We will interact with the master machine of Kubernetes using kubectl. The kubectl requires one file called kubeconfig file. That file has the information about the master machine details and username, password to connect to the master machine. So this kubectl requires one file called kubeconfig file. That file will have information about the master machine API server and username, password to interact with the master machine API server. So this will interact with the master machine to deploy the applications or to delete the application. Now, what is API server in the master? What is scheduler? What it will do? What is control manager? What is etcd? So in master machine, you have API server, scheduler. In master machine, you have a API server, scheduler, control manager, and etcd. What is the role of master? Like any other cluster, master node is responsible for managing the Kubernetes cluster. It is the entry point for all administrative tasks. Like, you want to deploy some application, you want to create a value, or you want to delete the application. So it is the main entry point for administration task. It handles the orchestration of worker nodes. The master machine will orchestrate the worker nodes and its containers. There can be a more than one master node in the cluster to achieve fault tolerance in the master. We can have more than one master also in Kubernetes to achieve high availability in the masters. So each master machine will have this API server, scheduler, control manager, and etcd. What is the role of API server? In the interview perspective, also very important, guys. They will ask you to explain Kubernetes architecture. What are the components will be there in the master? What are the components will be there in the worker? So master machine has these components: API server, controller, scheduler, and etcd. What is API server? Right. API server is the entry point or entry point for our Kubernetes cluster. API server is the entry point for Kubernetes cluster. It will interact with the API. What is API in general term? What is the full form of API? Application programming interface. So Kubernetes is developed using some language called Go language, right? So whatever commands we execute, first request goes to the API server. Whatever commands you execute, kubectl commands, kubectl commands, request goes to the API server. API server will process our commands, right? It will execute some programs. Kubernetes API server is the entry point for Kubernetes cluster. It will interact with the API, some programs. It is front end for Kubernetes control plane. Kubernetes control plane is nothing but again master. It's a front end for Kubernetes control plane. All the kubectl commands or kubectl commands will interact with API server. It's a communication center for developers, system administrators, and other Kubernetes components. What is the role of API server? Any request you want to deploy some application in the worker machines, some containers, or you want to delete some application from your Kubernetes cluster. You want to create a value. Any request will go to the API server. And API server will manage the commands. It will execute the commands. It will do something. Then we have one more component called scheduler. In Kubernetes, we are going to create a containers, but the containers will be wrapped under one more Kubernetes concept called pods. In Kubernetes, we will create a pod. Pod will have a container. We will discuss what is pod, how to create a pod. In Kubernetes, we are going to create a pods. If you see, we have a pod. Pod will have one or more containers. Within the pod, you can have one or more containers. So we will discuss what is pod later. So now, scheduler, what scheduler will do? Scheduler will watches the pods, unassigned, like an unscheduled pods, and it will assign the pods to the, it will assign the pods on the worker machines. Suppose I want to deploy one application here. I am going to execute some command. kubectl command to deploy application pods. Pod is basically, pod will have a container. So the moment I execute any kubectl command, first request goes to the API server. What API server will do? It will save the information, your pod information, like what, from which image you want to create a pod, how many pods you want to create, what is the image name, what is the port mapping, the complete information, your pod information will be persisted in a etcd. First request goes to API server. API server will persist pod information or request in etcd. So what is etcd here? I am trying to deploy one pod. Pod will have a container. I am trying to deploy one container in Kubernetes. I requested using these commands, kubectl command. Request goes to API server. API server will persist the information in etcd, your pod request information. So what is etcd? I will come to the scheduler. What is etcd now? etcd is a simple distributed key value store. etcd is a database, like etcd is a database for Kubernetes cluster. What it will maintain in the etcd? It is not application database, right? It's a Kubernetes cluster database. So etcd is a key value data store. What it will have? It will have Kubernetes, or it will maintain Kubernetes cluster information. It's a database for Kubernetes cluster. It will maintain or it will have nodes information, how many worker nodes I have, comma parts information, how many parts we have in this cluster, right? Volumes information, etc. There are a lot of information. So etcd is a key value data store for Kubernetes cluster. It will maintain cluster information like how many nodes I have, how many parts we have, what are the values, all the information will be maintained in the etcd. So whenever I want to deploy some application, I will request via kubectl. The kubectl will talk to API server. API server will persist the information in the etcd. So then what scheduler will do? Scheduler will watch unscheduled pods. Scheduler will check the etcd. Scheduler will check the etcd and it will identify is there any pod which is not scheduled. I mean to say which is not created. Scheduler will watch unscheduled pods and it will schedule it to worker machines, worker nodes using kubelet, which is running on worker nodes. So what scheduler will do? Scheduler will watch etcd. It will identify is there any part which is not yet created. Is there any part which is not yet created? So the scheduler will watch unscheduled parts and it will schedule it to worker nodes using kubelet, which is running in the worker machine. We have a kubelet here, right? So it will talk to kubelet or any kubelet. It will talk to worker machines kubelets and it will see, it will schedule the parts. It will create a parts in the worker machines by interacting with kubelet. It will check with kubelet, do you have some space? I want to create a parts in your machine. Do you have any space? Is everything is perfect in that machine, right? It will interact with kubelet and it will create a parts here. And what is the role of control manager? So it will talk to kubelet and we will get a pod here, maybe in the worker machine. I will get a pod here. This is pod. Basically, pod will have a container. This is where our application is running. The kubelet will talk to this one, containerization. This is fourth step. Kubelet will talk to container, this software, Docker, and it will create a container. Container. So we will get a container. The container will be wrapped under the pod. We will discuss how to create a pod later. Now coming to the master machine. Any request, API server is a front end for Kubernetes cluster. The command, we are using kubectl, CLI. Any request which I wanted to do something in the Kubernetes cluster to deploy application or delete application, we will execute some kubectl commands. Kubectl will interact with API server. API server is a front end for Kubernetes cluster. The API server will persist the information in the etcd, our pod information, like node information, everything we will have in the etcd. etcd is a key value data store for a Kubernetes cluster. It will maintain Kubernetes cluster information like nodes information, pods information, volumes information. Scheduler will watch the unscheduled pods and it will schedule it to the worker nodes using kubelet, which is running in the worker machine. Then what control manager will do? What is the role of control manager in the master? We have a lot of control managers like node control manager, replication control manager. Right? The control manager will monitor or it will manage the pods or it will manage the machines. We have a control manager. Control manager runs in the background, which will do a different task, Kubernetes task. It will do some functionalities like replication. It will make sure you have enough number of pods always. And it will keep a track of worker machines, like it will monitor your worker machines. How many worker machines are there, whether those are up and running or not. It will handle pod failures and also it will handle node failures. We have a lot of control managers like node controller. What is the control manager will do? We have a node controller. It is responsible for noticing and responding when node goes down. It has a lot of control managers like this. Node control manager, replication control manager, etc. This node control manager will notice when node goes down and it will respond. If some of the node goes down, what we are expecting? If some worker machine goes down, what we are expecting? The pods, the containers should move to the another machine. So the node control manager will notice when node goes down and it will take some action. It will move the pods to another machine. Similarly, you have a replication control manager. This replication control manager will keep a track of our replicas. the pod replicas. If your pod goes down, the replication control manager will recreate the pod. It will notice that this pod is down. It will recreate the pod. Control manager will take care about these things. These are the master machine components. In worker machine, you have a kubelet and kube proxy. What is the role of kubelet and kube proxy in the worker machine? In worker machine, you have a kubelet, kube proxy, and container runtime. Worker machines, worker nodes are the nodes where the application is actually running in Kubernetes. Our application pods will not come in the master machine in Kubernetes. Our application containers will not come in the master machine. It will create only in the worker machine, our application containers in Kubernetes. Worker nodes are the nodes where our application is actually running in Kubernetes cluster. It is also known as minion. So this server, we will call it as worker node, slave, or minion. All are same. In Kubernetes, worker node, slave, minion is nothing but the machine, worker machine. This one we will call it as a master node. Each worker nodes are controlled by the master using kubelet process. We have a kubelet here, right? The master machine will control this worker machine. The master machine will manage or control this worker machine using this process, kubelet process. Master machine will interact with kubelet and it will manage this worker machine. So we should have a containerization software in this machine like a Docker. So as I told, Kubernetes supports not only Docker, it supports CoreOS, Rocket, other containerization software. So in Kubernetes worker machine, we have these components. We have a kubelet and kube proxy. What is kubelet here? Kubelet is a agent, primary node agent, which will run on each machine, right? So it's a agent for the master. Kubelet is a agent for the master. Master will talk to the kubelet and it will do the cluster functions. Kubelet is the primary node agent, runs on the each nodes, and it will ensure that containers are running and healthy. The kubelet will ensure that containers are running and it is healthy. So it makes sure that containers are running in a pod, and kubelet doesn't manage the containers which are not created by Kubernetes. Suppose you have not created a containers using Kubernetes, you directly executed Docker run in that machine. Those containers will not be managed by Kubernetes. Basically, kubelet is a agent, node agent for the master, which will master machine will interact with this kubelet to manage the containers or machines in this worker. And we have a one more component called kube proxy. So kube proxy is for communication. How can we access the applications which are running in Kubernetes cluster, right? Either internal communication or external communication, right? So it will use kube proxy. Kube proxy will help us to have a network proxy and the load balancer for service, right? So we can access the applications which are running in a Kubernetes cluster either internally or externally with the help of kubeproxy. So we have a container runtime. We have a containerization runtime like a Docker, Rocket, or CoreOS in the worker machine. These are the important components. In the master, you have this. In the workers, you have a kubelet and kubeproxy. In the interview perspective, also very important concept, Kubernetes architecture. And also, now you should be able to understand which component will do what job in the Kubernetes cluster. Now coming to the installation part, there are a lot of ways we can install Kubernetes cluster. We have self-managed Kubernetes cluster, and we have a managed Kubernetes cluster. Managed, I mean to say platform as a service in the cloud. We can create a Kubernetes cluster in lot of ways, like self-managed Kubernetes cluster and cloud managed services. Cloud managed services. Platform as a service like EKS, AKS, GKE, Elastic Kubernetes service, Azure Kubernetes service, Google Kubernetes engine. And we have a self-managed cluster. Kubernetes can be installed in Kubernetes cluster can be set up in multiple ways. Self-managed Kubernetes cluster and cloud-managed Kubernetes cluster. In self-managed Kubernetes cluster, I can use some softwares like Minikube or Kubidium softwares to set up a self-managed Kubernetes cluster. What is self-managed Kubernetes cluster and what is cloud managed? What is self-managed Kubernetes cluster? We are managing the cluster. We are creating the servers. We are managing the Kubernetes cluster. Self-managed, we are managing the Kubernetes cluster. You need to create a Kubernetes machines. You need to create a servers. You need to set up all these things. Self-managed, you are creating a Kubernetes servers. You are setting up all these components yourself. And when I go for managed services or managed Kubernetes clusters, EKS, AKS, GKE, these are the managed services. In AWS, we have Elastic Kubernetes as a service. In Azure, Microsoft Azure, you have a AKS, Azure Kubernetes service. In Google Cloud, GCP, we have one service called Google Kubernetes engine. This is managed, cloud managed. And also I can set up a Kubernetes cluster using one more software called KOPS. Kubernetes operations. There is a software called KOPS. Using that also I can set up a Kubernetes cluster. But what is the main difference between self-managed and cloud managed? If you created a self-managed Kubernetes cluster, if something goes wrong with master machine, If something goes wrong with worker machine, what will happen? If your parts are down in Kubernetes cluster, if your parts are down, your Kubernetes master machine will try to replace the parts. If your part is down, it will try to create another part. But I am asking, in case of self-managed Kubernetes cluster, we are setting up all these components. If something goes wrong with master machine, will I get another master machine? In case of self-managed Kubernetes cluster, I need to fix the issue. If something goes wrong with your worker machine in self-managed Kubernetes cluster, if something goes wrong with worker machine in self-managed Kubernetes cluster, what Kubernetes can do? Master machine is running, this worker machine is down. What max self-managed Kubernetes cluster can do? The containers or the parts will move to another machine. Will it fix the machine issue? I mean to say, do you get another worker machine in case of self-managed Kubernetes cluster? You will not get another worker machine. You need to fix the issue. But whereas if I go for a cloud managed, or we will call it as a managed service, managed Kubernetes service. If my Kubernetes cluster is this EKS, AKS or GKE, or if I set up a Kubernetes cluster using KOPS, it's a managed Kubernetes services. These three are managed Kubernetes services, cloud managed. We are not going to create the servers. We are not going to set up all these components. The cloud will take care. The provider will take care. If I go for a cloud managed services, if parts are down, Kubernetes will take care. If your infrastructure is down, your infrastructure like your servers are not running, your server goes down, your master machine goes down, or your worker machine goes down. So infrastructure failures also will be taken care if we go for a cloud managed Kubernetes cluster. If some of the worker machine goes down, automatically I will get another worker machine. Who will manage this? Who will take care about the infrastructure failures? If I go for a cloud managed Kubernetes cluster, the provider who is providing the service. If pod is failed, Kubernetes will take care. If pod is failed in Kubernetes, you have a control manager, etcd, scheduler, API server. Application failures will be taken care by Kubernetes. The infrastructure failures will be handled by the provider. If I go for a cloud managed services. So in self-managed, we have a Minikube and Kubidium. This is single node Kubernetes cluster. We will not use in real time. Single node Kubernetes cluster. This is just to practice. Using Kubidium, we can set up multi-node Kubernetes cluster. Using this Kubidium software, we can set up a multi-node Kubernetes self-managed again. This is self-managed Kubernetes cluster. We need to create a servers. We need to set up all the required Kubernetes components. We can use this software. Or if your project is using a cloud, they can go with managed services. Suppose your application, like you wanted to use Kubernetes, but your project, your team is not ready to move to the cloud. They are not, they don't want to use a cloud for the infrastructure. They wanted to do all the deployment in the data center servers, on-premise data center servers. If they want to do the cluster setup, Kubernetes cluster setup in on-premise data centers, they cannot go with this cloud managed services. Like some banking applications, they may not use cloud like AWS, Azure, they may not go with cloud. In that case, if they want to use Kubernetes clusters, what is the option? They can go with this cloud managed, or they have to do self-managed, right? Self-managed Kubernetes cluster. In case of self-managed Kubernetes cluster, application failures, the pods or containers are failed, Kubernetes will try to replace the pods or containers. But if we have issues in the infrastructure level, Kubernetes cannot do anything. You need to take care about the infrastructure failures. But when we go for a cloud managed services, application failures will be handled by Kubernetes. Infrastructure failures will be taken care by cloud provider. So first I will explain how to set up a Kubernetes cluster using KubeDM, self-managed Kubernetes cluster. Later we can see how to set up a Kubernetes cluster using KOPS. I will explain this one. Okay. So we will discuss about installation after the break. We will try to set up a Kubernetes cluster using KubeDM. We'll continue from 8:45. Now I will try to set up a Kubernetes cluster, self-managed Kubernetes cluster using KubeDM. So you can set up Kubernetes cluster using KubeDM in on-premises data servers, and also you can set up in the cloud also. So we are managing the cluster. We are creating the machines. We are installing the required components to set up a Kubernetes cluster. So for this one, I am trying to take 3 machines. 1 for master and 2 for workers. So I will share this installation instructions to set up a Kubernetes cluster using KubeDM. So we will take 3 servers. 1 for master, 2 for workers. Master machine minimum you should have a 4 GB RAM and 2 core processor. So for master machine, I am taking T2 dot medium machine. For worker machines, I am taking T2 dot micro machines. So let me create a 3 machines in AWS. Let me log in. So let me log in. So now I will try to create 3 machines to set up a Kubernetes cluster. For master machine, I am going to take 4 GB RAM and 2 core processor. So I'm going to take T2.medium for master machine, and I am selecting Ubuntu server. And we need to open the ports the way we opened some ports while setting up a Docker Swarm cluster. We need to open the ports for Kubernetes cluster also. So in master machine, you need to open these ports 6433, TCP 6433 for API server. API server will be running on 6433. For etcd, we need to open 2379 and 2380 port for etcd. So 10250 and 10251 for scheduler, 10252 for control manager. You need to open all these ports in the AWS security groups for the master machine. But for now, I will open all the traffic. For now, I'm trying to say all traffic. I'm trying to open for anywhere, but when we are opening, open only for, in the real time, we will open only for only these ports in the master. For now, I am opening all the traffic while creating a master. Similarly, I will create 2 more machines for workers. I'm going to create 2 more machines, Ubuntu machines for workers. For workers, we can practice with the T2.micro itself. So that is fine. Let me come back. I have to open the ports. So in the worker machine also, you need to open this port 10250 for kubelet. And this is not required, like the range 30,000 to 32,767, this node port service. We will discuss what is this node port later. We need to open 10250 because kubelet will be running on 10250. So for now, I am opening all the traffic in the worker machine also. I think I'm creating only one machine. Let me go back. I will create 2 servers because I need 2 machines. So I open the traffic. So this is T2.medium. I wanted to use for a master machine. These 2 are I'm planning to use for a worker machines. So let me tag. First, let me give a tag. Kubernetes master. Kubernetes worker 1. Kubernetes worker 2. First, we need to install a lot of softwares to set up the Kubernetes cluster. First, in these machines, in all the machines, I should have a containerization runtime. I need to install Docker in all the servers. And I need to install some softwares like KubeDM, Kubelet, kube proxy softwares. So once you create a servers, these are the common softwares which we need to execute in both master machines and worker machines. Here I have given common for master and slaves. Okay. First, I am installing required softwares. I am adding the Kubernetes package keys. Here I am just adding Kubernetes package keys. And here I am disabling the swap memory. So we need to disable a swap memory in all Kubernetes machines as per the official Kubernetes documentation. If you enable the swap memory, it will not work. If you enable the swap memory, Kubernetes cluster setup may have some issues. So we need to disable the swap memory in all the machines. So by executing these commands, we are disabling the swap memory. Then we are installing Docker. We are installing Kubernetes softwares like Kubelet, Kubedium, and we are starting the services, Kubernetes services. We are enabling the services. These are common for both masters and workers. You need to execute these commands in both master and also in the worker. So let me log into machines and I will execute all these commands in all the machines. Let me connect to master machine. I connected to this machine. So follow these instructions. First switch to the root user and execute these commands. While you are installing, guys, do one by one. Log into one machine and execute all the commands one by one. You need to make sure you execute all the commands. You should not skip any command. For now, what I will do, I will parallelly open all the three machines and I will parallelly execute, but you guys do one by one. I am opening another tab also. I log in to this machine as well. I will log into this machine also. But while you guys are doing, try to do one by one. So let me switch to root user in all the machines. So now what I'll do, we'll first update the package manager. I will do in all the machines. Install required software. Downloaded the Kubernetes key, software key. Then I am adding the entry in the apt file, source file. So I am creating one file in all the three machines. Then I am making an entry in that file. Then end of file, EOF. So the file will be saved. Then again I am updating package manager. Then I am disabling the swap memory permanently in etc fstab file also. Then install Docker. And this step is optional. You no need to add Ubuntu user to the Docker group, because since I am using Kubernetes, we are not going to execute Docker commands. Since we are using Kubernetes to to deploy the applications, we are not going to execute Docker commands. So this one you can skip. You no need to add Ubuntu user to the Docker group. It's optional. So then we are just restarting the Docker, and we are enabling the Docker service on boot strap. Then we are installing Kubernetes related softwares in all the machines. Then we are just starting the kubelet service, starting and enabling the kubelet service. So the common softwares has been installed in all the machines. Then how can we set up a master? Like now in master machine, I need the API server, control manager, scheduler, right? So as of now, we have just installed the common softwares which are required in all the machines. In all the machines, we installed common softwares. Now in the master machine, how can I set up a master machine? In master machine, we already switched to the root user. This is only in the master. We already switched to the master. I am on the master machine. This is my master machine. I wanted to use this one as a master machine. We already switched to the root user. We are executing this kubedium init to initialize the master. Basically, this kubedium init will do this. It will create a API server. It will create a scheduler. It will create a control manager. It will create a etcd. The moment we execute kubedium init, the master machine will try to set up. It is going to download the required images. Again, the Kubernetes API server, control manager, etcd, all these things will be running as again pods. So it is this kubedium init will download the parts, and it will download the images, and it is going to create these master machine components, API server pods, scheduler pods, control manager pods, etcd pods. It will take some time to come up to create all these master machine components. Now, if you see the output, the moment I execute kubedium init, it has done something. It is generating some files and it is creating those things. Now, if you see, you got a message. Your Kubernetes control plane has initialized successfully. To start using Kubernetes cluster as a regular user, I want to execute kubectl commands as a regular user. To start using Kubernetes as a regular user, run the following commands. Now we need to run these following commands as a normal user. So as a which user you want to run the Kubernetes cluster commands, right? So you need to run these commands. If you see, we have one config file and we are creating a kube config file from this one. What is there in this one? We have our Kubernetes information, like the API server, the master machine IP address, and API server is running on 6433, right? So API server is the front end for any cluster operations. kubectl, as I told, kubectl is a command line interface. kubectl requires this file to interact with the master machine. So that's what we are doing. I want to execute kubectl commands as a normal user. As a normal user, first I am creating a .kube folder in the user home directory. We are creating a kube config file. We are copying this content to this kube config file. Then we are changing the ownership. These three commands I should not execute as a root user, because you want to execute kubectl commands as a normal user. So now I am in root user. So let me come to normal user. Now I am as a Ubuntu user. So execute these three commands. Now we are good to execute kubectl commands. Kubectl, I can execute now cluster info. Now it is saying Kubernetes master is running on this IP address and this is the port number, API server. Now kubectl get nodes. As of now, I have only one machine, this one. This is the master, kubectl get nodes. This is the master machine. In the same machine, I have a kubectl installed, CLI. The kubectl is talking to this one, same machine. You can configure kubectl in a different machine also. In the same machine, I have a kubectl, and this file has my Kubernetes cluster information. Kubectl get nodes. As of now, I have only one machine. Still, that is not ready. We need to create one more component. Why it is not ready? Let me show you. Kubectl get pods --- all -namespaces. I want to see the pods which are running in all namespaces. If you see, in the master machine, we have a scheduler, we have a control manager, we have a API server, we have a etcd. But why this is not ready? The DNS is still pending, domain name service. There will be a part for DNS service. It is not yet ready. That is because we need to create a network. The way we have a overlay network in Docker, in Kubernetes, we need to apply some network. In Kubernetes, we need to apply some networks. There are a lot of network plugins. There are a lot of network plugins. So if you see, I opened one link, official Kubernetes link. We need to apply some networking. We have a lot of networks like Calico network, Flannel network, ViewNet, right? So we need to apply some network. So here I am going to apply one network. If you see, I executed this one, kubectl get pods. Let me, in master machine, if you see, this is the IP address of master machine, same machine. API server, etcd, scheduler, kube proxy, everything is running except this one. This is requires some network plugin. We have a lot of network plugins. We need to apply any one of the network plugin. So I am going to apply this one, ViewNet. There is a network called ViewNet. I am applying this network. Now if I see again, I am getting a network plugin. If you see ViewNet, once this is ready, this pod is ready, ViewNet network pod is ready, then DNS will be up and running. So the ViewNet pod is coming up. Once that is ready, this will also be ready. Let's wait for some time. Now one of the DNS pod is running. I am getting another one also. Now my master machine is successful. kubectl get nodes. So kubectl, my master machine is ready. Now how can I add the worker machines? I need to add these two machines. I need to add these two machines to the cluster. When I executed kubedium init, I got a token, but I cleared the screen. So from master machine, I need to get a token. So from master machine, I need to get a token. In the master machine, I am executing one command. So first one, ignore this one. This is a warning. Okay. So the second line is our token. The token is kubedium join. This is the token, second line. First one, just ignore. That is a warning. So this is the token, kubedium join. What is this? 172.31.40.104. The IP address of the master machine, private IP. 172.31.40.104, private IP address of the master machine. And what is this? 6433. What port? 6433. What is the port? Which component port? In Kubernetes, we have a lot of API server, scheduler, control manager. Which port that is? Right? That is the API server port. So API server is the entry point for any Kubernetes task, like you want to add a node, you want to deploy a pod, right? So now this token I need to execute. Where I need to execute this token? Go to the worker machine. If I execute as a normal user, I will get a error like this kubedium command. I can execute as a root user. So you can do like this. Either you use sudo then command, or you can switch to the root user. Switch to the root user and execute. In this machine also, I can execute with sudo permissions or switch to the root user and execute. So now these two machines will be added to the Kubernetes cluster. Now, if you see, still it is getting ready. It is not yet ready, it is getting created. So what is going to happen in this machine? It is going to create the API, this one, kube proxy. Kube proxy will be getting created here and kubelet will be there. So kube proxy pod is getting ready in these machines. After some time, if you execute, you can see this is going to be ready. Before that, let me see the pods. If you see in the worker machines, this is one worker machine, right? And we have a one more worker machine, this one. Kube proxy pod is getting ready and network pod is also coming ready in that machine. So once those are ready, your cluster is ready now. So now I have a Kubernetes cluster ready. kubectl get nodes. I can see I have a master and I have two workers. We have created a self-managed Kubernetes cluster using Kubedium. Now, how do I deploy my application in Kubernetes cluster? What commands I can use to create a Kubernetes cluster? I mean to say the containers, application containers. In Kubernetes, we have a concept called pod. First, we need to create a pod. Pod will have a container. Inside the pod, we will have a container. So what is pod? How to create a pod and how to access the pod? I mean to say, how can we access the application which is running as a container inside the pod? And we have a lot of Kubernetes objects, like what is Kubernetes namespace, kubectl get ns namespace. Or I can execute like this, kubectl get namespaces. As of now, I have these many namespaces. In this namespace, some pods are running, some services are running. So these are Kubernetes related pods, right? So what is namespace? What is pod? If you see some service is there, what is service? What is daemon set? What is deployment? What is replica set? So we have a lot of objects in Kubernetes like namespace, pod, right? Like these components. We have like pod, replication controller, replica set, daemon set, deployment, service, value, namespace. We have a lot of Kubernetes objects. First, we will understand what is pod, how to create a pod. What is the problem with pod? Why do we need this replication controller, replica set? What is daemon set? And what is deployment? What is service? So slowly we will understand. Tomorrow, first we will try to understand what is namespace and what is pod. How can I create a pod and how can I access the application which is running in a pod? Tomorrow we will discuss. For today, You just set up a Kubernetes cluster using KubeDM self-managed Kubernetes cluster. Tomorrow we will continue with actual Kubernetes objects.